everyone, and welcome to our tech session for today. If you came in from our previous meetup, thank you for joining this one, and thank you to any new guests joining. Today, Ramsey is going to be taking us through feature engineering, which is essentially the process where you take raw data and transform it into meaningful, relevant features that help with model performance. So he's going to take us through the feature engineering that we have on our own ecosystem AI workbench and how that can be used and applied to some use cases. Hey, Ramsey, can you kick it off? Thank you.
Thanks, Madison. The presentation ready. Just get that up quickly. Share screen. Is my screen coming up?
Yes, it is.
There we go. All right, thanks. Just say thank you for everyone for attending this session. Like Madison said, we're going to be looking at feature engineering and more specifically the different types of options of feature engineering that we have available on the ecosystem platform. Obviously, as a feature engineering, well, maybe before I get into that, let me just start with the introduction of what feature engineering actually is. So as Maddie now said, it is the pre-processing data preparation step that you take beforehand. Change, mold, restructure, look up data, and get it into a format that is usable by your kind of machine learning models. What's interesting, people might not be familiar, is this process, especially when you're working with big corporates, is an incredibly tedious process of grouping it together with data management in general. Like getting the data, cleaning it, enriching it, that whole process is time consuming. It's kind of a function of, like I said here, 20 to 60% varies widely depending on what you're doing and how you're trying to do it. So the quality of the data set is going to be a big issue as well. If you have incomplete data sets or data sets that were truncated incorrectly. An interesting example we had earlier this week is we had company that is doing vehicle insurance, and they have obviously this list of cars and models and things, and one of the cars is a Fiat 500. Now the fact that a 500 is a numeric and not a string is, when you're working with data, is an issue. So that's like the data is not clean in the sense because that data was not structured as a string, it was structured as an integer. So things like that of how data is structured is going to be immensely consuming if it's structured badly. And when you're looking at large data sets of large corporate clients, they usually have their data spread out over multiple data sources, and getting them together and being able to parse them and connect them in sensible ways can take very long. What's important with feature engineering is it's a bit more of an art than a science. There's no like do these 10 steps and you're going to get the right answer. It's extremely iterative. You're going to be creating hypotheses saying, I think this is a good way to approach it. I think these data points or these features are going to show a lot of value. Then you go about generating those features and testing them. And if you see that they have value or not, you might go like, oh, this feature is not working the way I think it would. Now you have to come up with hypothesis number 2. Why is it not working? Is it not working because of X or because of Y or because of Z? And you're going to keep on testing until you get to a point where your data is structured. It depends on in case, until your model is performing to the level that you are happy with. That can, depending on the use case, needs to be incredibly accurate, incredibly, what's those terminologies like precision and recall. There's this concept I would have been maybe nice to have an image of it up. I'm just thinking of it now. Look on a fusion matrix, and it basically tracks how good model is at retrieving or creating predictions based on previous data. It'll show you all of your true positives, your false positives, your false negatives, and your true negatives. Depending on the proportion of those, you kind of get these sub measures. There's a lot of people who just think, oh, accuracy is the best measure. But accuracy can be an incredibly bad measure if, say, you have a data set where 99% of the results is no. Like it's a thing that not a lot of people want to do. It's just say yes or no, buy my product or not. 99% of people don't want to buy the product, 1% wants to buy the product. If you have a model, I can just make a model that all it does is says no the whole time. It's going to have a 99% accuracy because it's right 99% of the time. But it's not a very useful model because it just says no the whole time. So this is where things like precision come in. Precision is more a measure of how good you are at predicting the success rates, and recall is kind of the inverse. So it is like if it is successful, did you predict it was correct? So just a few different measures of tracking model performance. Depending on your particular use case, precision is very important when your prediction has severe consequences. So something like a medical diagnosis, like telling someone they have cancer when they don't have cancer, is probably, well, maybe that's not a good one, because you probably want to rather be overcautious there. You rather not want to have people who don't have cancer tell them they have cancer instead of people who have cancer not tell them they have cancer. So then you want to focus more on recall, but I think you guys are going to get the point. It's very use case dependent on what your success metric looks like at the end. So there's no real fit-all process that you can follow. So I'm going to go through this set of enrichments that we have included in our environment because we think they are either completely raw, so it's stuff that you're going to be doing all the time. It's not particularly clever or anything. It's just these are stuff you're going to be doing a lot. So it's just easy to have that straightforward in there, or it's very specialized use case specific. So just to give you a quick overview of how we group these things. Like we talked before about data cleaning as a whole suite of enrichments, this is going to be around how do you deal with empty fields? Do you want to just treat them as empty fields? Do you want to remove them? Do you want to look at what the median value for that category is and just replace it with a bunch of different stuff you can do? And around things like maybe the text is uppercase, it's things like that. It's just standardizing, making sure the data is in a cohesive, standardized format. Then we have our transformations. This is where you're making actual changes to the data by either changing things in place or just adding things in. You're going to do basic transformations and stuff like the field concatenations, where you like adding fields together and things like that. Then you have your more time series based stuff. So this is where you want to either kind of make your data on particular time steps. So instead of dealing with each individual data point, you want to look at all of the data in hour basis. So for this hour of this day, what happened? You might have reasons you want to do that instead of looking at it at different granularities. It's about just playing with the time values or the time groupings of your data set. If you want to do that, with our natural language processing suite, this is where you're dealing with people writing. So you just have very low level interactions where you don't really have people writing text. So we have stuff like sentiment analysis or toxicity level tracking. You can do personality tracking, things like that. So we're getting into our more advanced set of things. And then we have our advanced transformations. This is our stuff that's very specialized. It's just kind of our catch-all group for all the things that don't really fit anywhere else. It's just a bunch of stuff that do very specialized things. I'm not going to get to there. And then we have our database operations. This is where you want to link information from different sources together. So it's like different kind of lookups and things like that. So yeah, I'm basically going to go through each of these, briefly explain them, and show an example here and there of how to do it on our site. So if you have any questions at any point, just stop me if you want more information about a specific thing or something I'm doing on our workbench is not clear. So first we're going to look at the data cleaning. One of the things you can do is zero fill. So this is basically when you have blank values, fill them with whatever the null value for that data type is. So a string would just be an empty string, and numeric would just be a zero. It's just a way of dealing with null values in your data set. The alternative of that, if you don't want to fill it with zero, you can fill it with values. So here you will once again find all your empty fields for a particular column and fill them using some kind of lookup. So you either use the average or get the median of all the ones that are successful, things like that. You can do. Then you have flattened subdocuments. So this is going to be important for people who are familiar with document stores. So we, as an ecosystem, prefer to use underlying document-based stores. So we use MongoDB, self-store, and they have a non-structured kind of data storage ability. So you don't have to define a schema beforehand like you do in SQL databases. It just allows you to add arbitrary data. It looks kind of like, I think it just uses JSON format. So if you're familiar with that, you would know what it looks like. You have a document inside of a document. So you have a bunch of fields, and a field's value can be another document. There's like subfields in them. And sometimes that's useful. Sometimes you don't want that. The flattening subdocuments, essentially what it does is it just like pushes all the subdocuments up a level. So if you have a car field, and under car you have model license plate number, and you just flatten it. You're just saying, take all of those leveled up and you just call the fields car, license plate, car, model, car, whatever. Then you have remove key. If you find you have data in your database that is either not egregious, not the word, but like duplicates essentially. This one has database, they store multiple data in slightly different formats, and you really only care about it in one way, you just remove it. Or if this field you don't need at all, you can remove it. Or make it a feature that you thought was good and it ends up being bad, you can remove it, just a way of removing stuff. And then you have remove documents. This is similar to what I said before about how to deal with bad data. You can programmatically search or query for particular documents that you don't want in your dataset anymore. So either if certain values are null, especially if you have some key kind of lookup information and that value is not populated, you can't use it for anything. So you might as well remove it. Or ideally go to the source and like ask them why is this data not structured correctly and get them to fix that in the long run. But in the short run, you probably just want to end up removing it and just get it out of there so it doesn't end up confusing the model in the long run. These are relatively straightforward, so I'm not really going to bother showing examples for this because, sorry, just give me a second. Oh, I'm clicking these things incorrectly. There you go. Yeah, so I'm not going to bother showing any of these, but we get on to our transformation type stuff. It's kind of another kind of suite of basic kind of transformation stuff you can do here. One thing that's especially just a way to kind of get a sense of your data before you even start hypothesizing is just to count enums. So enums, for people not familiar with this, is it just means enumerator. And while it sounds like it means number, it actually just means category. So if you have something like, let's take an example of cars, let's say car brands. There are 100 odd car brands, and the enumerator just tells you, well, enumerator is just the type of data that is a categorical based data. So it's not like free text. You're just saying this is a category that has 100 different types in it. And you can use this transformation just to get a kind of a count for each of those categories. So you can just get a sense for like, okay, this database has mostly Fords in them. Is that good? Is that right? It helps you to understand the data better and get a sense for how you want to start hypothesizing about your feature enrichments that you want to do. Then for concatenation, this is useful for when you want to basically combine the fields together, or categories or columns, whatever you want to call it, using all of the different database structures, terminology interchangeably here, but they all mean the same thing. I personally don't use this so much, but there are cases where this can be useful. It really depends on your use case. If you have data that is not structured 100% correctly, you might want to concatenate them or take two columns and use them to create one super column grouping. It can be useful for things like one-hot encoding. The enumeration builder, I can't exactly remember now what that one is used for. Let's just skip to the range to category. Range to category is one that I think is very useful. So especially when you're dealing with things that are not discrete or continuous data, let's take, for example, something like age. You can use that age as a straightforward value for your model. It's going to be a very high level of dimensionality for your model. So it's going to explode the complexity of it quite quickly if you have multiple of those fields. But is it really useful for you to treat a customer that is 25 different from a customer that's 26? Unless you have a very specific reason to believe so, it's probably not true. So what this range to category essentially allows you to do is to group continuous data and discrete data. So you basically say, like, for anybody that falls under age 0 to 10, they are children. Anybody from 11 to 16, preteens and teens. Anybody that's from 16 to 25 is young adults, depending on what you are selling and how you're selling it, or what you're trying to recommend. And those categories will make sense to you. So something, especially say you're a bank, you don't need to care about anybody that's younger and when can you open a bank. Someone's going to open a bank record for you. Let's maybe talk about phones or a better thing, a telecoms account or something like that. You can't really buy it yourself. You might be able to buy it for your children, but you're still the owner there. So anything anybody younger than 18, you don't have to worry about them. And then categorize these people into groups that are sensible to you. That's very useful. And then we have our generic aggregation pipeline. So this is just if you want to do any transformation. This is the way to get the Mongo's aggregation pipeline, which allows you to take data and manipulate it into any waveform you want to see. That's our way of clicking into it and making it easy. So essentially all of these things that I just mentioned now, you can do through the aggregate pipeline as well, especially very specific advanced ones and the low level document linking from ones all use the aggregate pipeline anyway. There's like more specific use cases. So maybe just to give an example, I think that range to category one is probably the most interesting. So I have to show you what this would look like. Where do I have my... Easier to do it. It's not this one, it's not this one, it's this one. Did this thing disappear? Hang on. I had it up right here before we started. Now I can't find it. I pulled it out as a single thing and lost it. That's fine, I can just find it again. This is the same site, so I can just go here. This one I haven't done it in a while. I haven't to do, and this is demo something. Feature next about. So I'm not going to talk too much about the workbench itself because we have other videos that do that. We have this drop-down data and features, go to feature engineering. This is where you can access all your collections and kind of look at them. Just prepare a kind of dummy data set here just for us to show the case these enrichments. So you go to your database, pick a collection. It's going to work on this transactions then. It's basically dummy banking data, like banking transaction data. But there's just 10 different transactions in here. And they are kind of, they show a few data points. It's not too excessive, just to show you what the different style things can do. The first thing I wanted to do was the data range thing. When you come in here, there's a lot of extra things you can do, and I'm not going to talk about, but the key thing we're looking at now is this enrich feature. So when you click on the enrich feature, you see there are multiple things coming up here. The one that we're interested in at this point is the range category. You click on that, drop down here and show you all the values you have to enter. This one, if you look at the data we have here, we don't have an age, but we have a transaction amount. Let's categorize this transaction into low cost transactions and high cost transactions. That's the easiest. So for the field, we're going to find that transaction amount. Then we're doing a search criteria here. This is where you can exclude things if you want to, or apply this enrichment to particular records instead of all of them. And you can add a search criteria. But in this case, we're just doing this blank one because we want to do all of them. Then we tell it what is the name of the new field that we want to create. So let's just kind of, for our own sake, give it a very similar name. So it can. And now we have to add the rule that we want to add here. So we have the example here. Let's just copy that to get the structures and type everything over. And then we say our range from 0 to 50 is going to give us a low spender, and 50 to 1,000 is going to give us a high spender. So just to make sure you guys use, there's nothing in here that looks like high or low spender. You typed in this, hopefully I didn't make any typos. We run that, and you can close this and just click the process button to find all the things we just generated again. And you can see I have this new category we just generated. And we see that this is 15 low spender, these are all low spenders, 6, 50, 32, we get to 79, high spender, high spender. It seems like that did exactly what we wanted to do. That's a very kind of straightforward kind of basic style you can do. Next up, now I have to find my presentation again. The next up we have our kind of date time series stuff. So our one that we probably almost always use just because of how useful this is the date enrich functionality. So what this does is you have any kind of date string in your database. Usually most will have, but some databases don't. Then you can use date enrich on it, and it will take that date string in whatever format you tell it to consume it, and build it out and get you kind of all the specific date field you might want. So it'll take things like extract the month, the day of the week, is it a weekend, is it a public holiday, the week of the year, all these things. It just basically takes all the potential date time combinations you might think of and generates them all for you. So it's quick and it's almost always useful. Most of the time just using a date straight is not going to be that useful. You might want to say, is it in the middle of the night? That's better than saying it is 2025 on the 7th of August at 7 o'clock, because that's not the thing you want to know at this point. The whole date is very useful. You might want to know what particular month it is, what time of day it is, what day of week it is, things like that. That's one that's always very useful. Then we have the time series features. This is what I kind of talked about earlier as well. This is when you want to group and categorize your data into time snippets. So instead of looking at the raw, very granular time series data, you might want to group them into more discrete groups. So whether that's a daily concatenations or hourly, there might be multiple uses for that depending on your use case. An example we use internally in our system is we do a minute-based nation on our logging data. It's just because Grafana, which is a data visualization system, can only handle so many million data points at a time. So when you start having hundreds of millions of data points that you're trying to display, it gets very slow and buggy. We concatenate it down to minute level just to reduce the load on that. So it's very useful for the number of use cases. You first have forecastability. So for those of you who understand what forecasting is, it's essentially just a statistical modeling approach to make a prediction, but it's very statistical. It's not all machine learning or data driven. So it's data driven, but it basically just looks at draws lines. So if line A is here and line B is there, what's the gradient extrapolated to its most obvious next point? If you have specific data, it can be useful to run this forecasting to see what the data might look like in a day or two. It's fun, it's whatever, it can be useful. So you go back. Let's just show an example of a data enrich. As I said, it is one of the ones we use almost always, and it's quite useful just to show you what it actually does. And so let's go back here at the same place. Let's click on enrich features. We just need to see what the field is that we're trying to be. It's this EFF reformatted. So we want to look at data enrich, come down here, say we want to use that. Just tell it which field to read from. I have to specify the format. So I tell it this field, and I have to tell it what the format is. This is kind of a standard data and format thing. If you want to know specifically how to use it, you can look it up. If you think this is the wrong way around, that should be lowercase m's, the capital M should be back here. I'm pretty certain M is for the month. And if I now process this, we should get data here around the different things. So before we just had the year date. Where was this original one? This is the one thing about records-based stores is they don't really know about orders. So they just give you random orders when you read up from it. So this is the original one. It was basically just a year, a month, and a date. And then we can look at things like telling us what the day of the week is. It's just showing us the year and the month. In a different format, year and month. It's the week of the year and the day of the week. It's the first day of the 29th week. Okay, this one isn't useful in this case because we didn't specify time, so it's just assuming 0 times. So this is all going to be morning. I can tell you the time of the day. I can tell you if it's a public holiday. Just tell you the month and day of the week. Bunch of things here. Date is epoch. So it generates all of these different date formats. Useful. The next up is going to be our NLP transformations. Also kind of talked this broadly before, but this is for natural language processing. So this is going to be when you have data that has kind of large text, not large, but not like a single word or 2 word or yes, please, whatever. It's going to be at least like a sentence or 2, or preferably long. You have your fragment options, NLP process you can do there. So it's things like remove, like it's kind of a grouping for a lot of low-level NLP operations. It's things like removing stop words, tokenizing, setting things to lowercase, things like that. Most of the time, you're not going to have a lot of use for that unless you want to go deeply into these processes. But we just have it in there because we had cases when we wanted to get into that. Then we have 2 personality predictors. So one is the big 5 personality types, and one is the MBTI. So the MBTI is the one that you're probably most familiar with. It's that kind of 4-letter one.
NFP or EN.
Yeah. Like thinking, feeling, introverted. It's this INTP. So it's like introverted, intuitive, thinking, perceptive. There's basically 4 categories, and each of them has 2, and you can get grouped into one of 16 depending on how you scored in the different ones. And the big 5 is just 5 personality types.
What I missed.
I was just asking if you recall what the big 5 personality types are.
Yes, it's also called the ocean model. So it's openness, conscientiousness, extroversion, agreeableness, and neuroticism.
Yeah. So these are kind of transformer models which take text and derives a personality from it. Obviously, the more personable the communication is, the better it's going to be. If it's a very specific corporate email, it probably won't perform as well. This might be better at looking at things like social media posts to get the personality from that. And then you have your name entity recognition. This is used to essentially extract proper nouns from text. So to get people's names, place names, company names, and things like that. Then you have your part speech extraction. This can be useful to kind of get a sense for how flowery the language is. So it's basically like all those things you learned at school, like how many adjectives are there, how many nouns are there, how many verbs are there. It just kind of breaks down all the things and gives you like a summary of what the text looks like. Then you have your summarize. This does what it says on the box. It takes the text, you tell it the kind of minimum and maximum bounds of your summary and reduces that text down to a 1,000-word document, and you say, I'm only interested in 100 words, summarize it for me in 100 words. It will try and condense all the pertinent information in the document for you in the amount of space you allow. Your sentiment model, this will go in and kind of get, basically, is the customer positive or negative about in what they said? It's going to tell you, are they happy? Are they upset? Are they kind of neutral? So this can be very good for customer service, seeing if people are calling in or sending in comments to get a sense of how they are feeling in the language they are using. And then you have your toxicity. This is useful for things like social media or potentially customer service stuff. It tracks metrics around vulgarness, sexual harassment, racism. It looks at text and decides like how bad it is. Bad in this case, like being how toxic it is, like how non-professional, things like that. So if you have a need for that, that can be very useful to set that up. Yes, I think that's, you can look at our advanced transformers. Like I said, these ones are the kind of more specific things that might not have like a greater, it's a specific to a vertical or specific to very specific use cases, but it's not like as generic. So the first one, I mean, yeah, you see the location extractor. So what this will basically do is if you have mentioned any kind of place name, so things like your city or your country or whatever, then it will find that and then go do a lookup to get you GPS coordinates for that, so longitude and latitude for that place name. So this can be useful if you don't have specific locations for people in your data set. I think we have a prediction enrichment. This essentially just takes a model, so any model you have prepared already, and you say on this data set, take these fields to feed into the model and write the output of the model into a new field. There are a lot of cases where you're going to have these kind of multi-tiered approaches where the output of one is going to lead to another. So a good example of that is our spend personality model, where we use the output of that to be a feature in further modeling that you're doing online. And our network process, which essentially takes your data, and if you have relative data, so data that has connections to each other, then you can build a network out of it. So you can then visualize it and they can look at how the network is connected, see what the centralities are and things like that, which is very useful. Then we have our ecosystem personality algorithms like spend personality and money personality and all of these things that you can use. These are essentially, like I said before, just predictions, but it's predictions that are commonplace enough and useful enough that we have standardized them, that you can just kind of use them in place. Also has a usage personality, which instead of looking at your transaction history, looks at your interaction history. So specifically on a website or on an app and things like that, your company does track what they are doing, how fast, where they are clicking and things like that. And this is a way to look at that data and get a sense of the customers. Are they very explorative? Are they clicking around a lot? Are they very determined? Are they like coming in and doing exactly the thing that they wanted to do? So you can kind of determine from that, and that's just another place for you to enrich your features and use that for your models you want to use eventually. We have some kind of code lookup stuff. A lot of companies have these generic IDs for these, like the MCC, the credit card codes. These are standardized codes that are used, by Visa and MasterCard. It's like standard codes that are used across the globe to encode information into that. Most of the time when you are looking at the data that customers, companies have, they only have the raw MCC codes, and you actually want to look up what do these codes mean. Like having a number 4987 doesn't mean much to me, but if you didn't go through the lookup, we have these standard SIC codes and MCC codes, and get additional information that is going to be relative to your model. And I'll show you, maybe just do an MCC one to kind of show you what the credit cards code stuff looks like. Because it's a banking transaction, we'll see that this person used the card to do something here. If you look further up, we'll see, yeah, so he did a prepaid buy or something with a card, buying some airtime off his car or something. And there's an MCC number of 480, but we have no idea what that means. So let's go enrich it so we can figure out what that means. Do that. And the field we want to enrich was called MCC, all caps. This section is complete, so we can now use that again, process it, and go view table. We're going to find it now because we have this massive transactional data. Maybe there's a few that gets set up here. So first off, we can see here we have our different categories. You'll see some of these says NA or unknown. The MCC value was, I think, like 9,999 or something. You see that. Yeah, so these are basically just your null values. Where we do have it, we can see this particular one. It's a food-based thing, purchase that we're making, food and dining. They were buying something at the grocery store. Okay, so we know that that payment, they were buying food. This payment, they were buying some kind of airtime or something. This person was buying fast food. So this is just standard codes that the industry uses. It's nice to look it up. It splits it up into discretionary or essential spending, which is also useful. Give you a sense. So there's a lot of specific things like that you can go around. And then our last one is going to be our database operations. So it's going to be a lot of lookup stuff. So the foreign key N to 1 and 1 to N is just your kind of standard kind of database lookups with foreign key N to 1. You're saying that for all of the values that have an X in my collection matching on the other side, so you're going to go to another database, do a lookup, and add it to each value in your current database. But foreign key 1 to N, you're kind of doing the opposite. You're saying for this document over here, for this value of column value X, there's going to be multiple records in this other database that has an X that you're matching up with. So pull all of those ones in and just append all of the names of this other columns of this record in here. This is just if you are trying to shorten names or to rewrite field names that are getting complicated, change them. And then you have your indexes. Indexes are not really part of the feature engineering as such. That is useful for when you want to speed your lookups up. So it essentially does stuff in the back end of the database. It takes a bit more storage space, but it vastly improves query speed. It's just kind of part of our feature engineering stack, because you're going to specify particular fields that you want to index. If you know that this is your key value in this field, index that value because that's the one that's going to be looked up. So when you're doing like a foreign key lookup, you know if you want to look up on a particular field, and it might be a big thing or a thing that you're doing frequently, you might want to just index it there as well. Just going to give you a quick example of what that would look up, because this foreign key lookup, especially depending on your use case and the data structure of your company, you're going to be doing this a lot to get a lot of data merged together. So it's an important one. I'll showcase it briefly. In this case, they're both in the same document store. So I have this other collection called day lookup that basically just has is days of the week, and it just has this number 147. Not very useful, but just to show the point. And because we did the enrichment, we have Monday, Tuesday, Friday. So let's just enrich that quickly to show you what it looks like. If we want to go to foreign key into 1. And we're going to say, what's the local lookup key? What's the name of this field in here? It's this here, formatted day of the week. And then database we want to look up from. It's called feature enrichments. Then is the lookup is called day lookup. And now we are saying essentially what the field is that we want to look up from that different table. The field we want to look up was just called value, but we want to call it in our new system. We want to call it day lookup. So we're matching how we're looking that up. So we're saying in our current collection, we want it to be called day lookup, and in the lookup table, it's called value. You can rename them, you can do whatever you want. Let's just call it day lookup so we know what we're talking. Make sure I don't make a mistake here. I think that's good. We can process this. Look everything up again. Now if we find it's a Monday, Friday. Now we need to find this field again. Day lookup. Where is it going? 15156145555. Yeah, and you can do that as many fields you want to look up as you want to, as few as you want to. A lot of times you can have disparate sets of data. You need to have them all in the same place to function or create this feature store for the models you're training. So a big part is connecting all the data sets together and getting the data that you want from specific places. Yeah, so I'm just going to talk a bit more about, I think I touched on this in the beginning as well, but just kind of reiterating it because it is very important. I'll show you like what's the best for your use case. The thing is, that's impossible to say because we don't know what your use case is. When you are thinking about starting feature engineering, you can't just do it ahead of time. That's very rarely or very few cases does it make any sense to do any kind of feature engineering preemptively. First, you have to understand what are you trying to do and how do you want to do it. You need to have a deep understanding of what you can do and what data you currently have. Once you understand that and know what you want to do, you also have to understand that it's going to be an iterative process. It's not going to be you plan this ahead of time, you do it once and it's done. You're going to be making hypothesis upon hypothesis and testing it and seeing that you're getting value or not getting value until you get to the core, the target output that you want. No single process will ever be the right one. It's impossible to know all the cases. We have collected feature and enrichment options together that we use most frequently in the companies that we have done work for before. It doesn't mean it's a all-encompassing list of everything you might want to do. There's a lot of things that you can do that we don't do that because it's either a one-off or it's something that we haven't ever used before. But then once you kind of have your features trained, and I talked about testing them, I'm not going to go too deep in this because we have other sessions that talk about model training and things like that. But how do you actually know if a feature is good or bad? So once you start training your models, you'll get these feature importance reports that come back and tell you like how useful was a particular feature in training this model. And useful in this case is how indicative it was of the predictor you were trying to predict. So obviously low is bad. Like if there's no prediction value, it's essentially, it means that this value might as well be a random value. It doesn't indicate anything. But on the other side, too high might actually also be bad because 99% of the time, if your feature importance is incredibly high, it's because you left in a value that is not indicative, but is actually a one-to-one relation to the thing you're trying to predict. So an example of that might be if you want to predict someone bought a car, but in your data set, you also have car insurance. This guy bought car insurance at the same time, and you added that to your list. The only way to buy the car insurance is to have bought the car. So it is going to be almost like a one-to-one indicator because it's impossible to buy insurance for a car you haven't bought. The things like that are also important to note. So generally what you want to end up having is the gradient slope. So you're going to see your most important features. It's going to be high, not too high. It's impossible to say, to give a number there with what's like obviously 100% is bad, but 90% might be bad as well. It could be bad. It depends on how your data is distributed and things like that. What you generally like to see is a nice gradient slope going from the most important one, just gradually kind of curving down to the bottom. Yeah, like once you find these features that are bad or good for whatever reason, and then you start trimming them, removing the ones that are clearly not useful to your model, and then refactoring until you get to that kind of precision and recall values that is going to be useful to your case. Yes, I think that's pretty much for me. I'm actually surprised that I got this done in time, or I thought. I don't know if there's any questions or comments from anybody in the chat. I don't know if there's any hands that I missed before.
No, there's nothing in the chat, but if anyone has any questions now, you do have 3 minutes to spare. If not, I don't have a question. I do have a comment, which is just to say that I was looking at this part of the platform today, or the workbench today, working on a use case. And I just remember in Reg saying, I don't understand. And now I do. So the timing of this meetup really worked out.
This meetup was just for you, Madison.
So I actually planned it that way. Yeah. But if there are no questions, I'm going to say thank you so much, Ramsey, for this very well-timed meetup. I'm really looking forward to hopefully doing work with this. Thank you so much for everyone who joined.
Thank you, everybody, for listening to me, and have a great day further.